Let's talk about number-based counting. This is really important to understand as a computer scientist. There are several bases in which you need to know how to count. Let's first review base 10. It's called base 10 because there are 10 counting digits. What are those 10 counting digits? They are the digits 0 through 9, as you see here. Those are all single character symbols that are used to represent the number of fingers you are holding up, or how many pennies you have in your pocket, or anything else like that. Once you run out of the single symbols, you must use combinations of two digits together, and the first two-digit combination in any base is always 10. In base 10, we call this 10. The next combination is always 11, which is called 11, and then 12, 13, and so on all the way to 19. Now, we have run out of all of the possible combinations where 1 is the first digit, so we must now use the next digit available, which is 2, and then do all of the possible combinations with 2 as the first digit, which go from 20 to 29. Next come all of the 30s, then the 40s, and so on. We as humans understand base 10 very well because we have learned it by rote from when we were very young. Now, let's try a different base. How about base 8? In base 8, there are 8 counting digits, which are 0, 1, 2, all the way to 7. Now, the digit 8 itself is not one of the counting digits in base 8. This is really important to understand. The reason is that the counting starts at 0 and then stops after 8 digits, which is at the 7. Again, the digit 8 does not belong in base 8. This may seem confusing at first, but if you think about it, it makes sense. The next thing to do is to think about the two-digit combinations needed after all of the single digits have been used up. Well, it's the same idea as we used in base 10, starting with 10 as the first combination. This is followed by 11, 12, and so on, all the way to 17. Notice that we did not use the words 10, 11, 12, and so on. Those words are reserved for use only in base 10. In base 8, this is not the value 11. It is the value 11, base 8, and that is the way you say it. The next combination is called 12, base 8, then 13, base 8, and so forth. Since 7 is the final digit in the base 8 system, the value after 17, base 8, is not 18, but rather the first combination with 2 as the first digit, which is 20, base 8, followed by 21, 22, 23, and so forth. Now let's do a side-by-side comparison of the values in these two bases. Here are the first 17 values of base 10, from 0 all the way to 16. Now see how the base 8 values align with these. You can see that the first 8 values are the same, 0 through 7. But starting with the base 10 value of 8, things change, as we've talked about already. Study these carefully and see how the two different bases compare. The most important thing to remember is that each set of values represents the same number of objects. For example, the values 8 in base 10 and 10 in base 8 both represent this many items. This could also be the number of sides on a stop sign, the tentacles of an octopus, the number of semi-cardinal directions on a compass, or the number of hours in a standard workday. These two values, 12 base 8 and 10 base 10, represent the number of fingers on 2 human hands, the number of pennies in a dime, or the number of months in the pre-Julian Roman calendar. To summarize, you need to know the fundamentals of how bases work and how to count in different bases. In the next lesson, we'll look at how to count in 2 other bases that are used quite often in computer science, base 2 and base 16.